Hello, everyone. You are welcome once again to today's class. And in today's lesson, we are still dealing with probability. But remember, we're dealing with probability questions which will allow the use of combination. So we're looking at combination approach, to solving probability questions. So in our previous lesson, we realized that we could use this approach, under three situations. When we are dealing with committee, or we are finding probability that involves forming a committee, when we are dealing with a probability that involves drawing items, at once, or drawing items, without replacements. In our previous lesson, we looked at questions related to committee forming. In today's meeting, we are going to look at questions involving selecting, or picking items from box, what have you, where the selection will be done at once, which will more or less be at the same time, or without replacements. So it could be one after the other, but without replacement. Immediately you see the keywords there, at once, without replacements, in terms of you selecting, items. You should know that the combination approach is very applicable there. So quickly, let's look at the first question before us. A box contains 3 red and 4 white, balls. If 2 balls are drawn at random at the same time, so you underline this. So immediately you see that the selection is done at the same time, not one after the other. Then you should know that you can apply the combination approach. So however, we will deal with the question our usual way, assuming we don't know how to use combination. And see whether we end up getting the same result. So we'll try it maybe for the first 2 questions, using our usual route, not the combination, approach, and we'll see whether we end up getting the same result. So what I'm going to do is, before we move on to, the combination approach, I want us to do something here, then you help me. Once the selection is done at the same time, indirectly, it means, the selection is done without replacement. Please take note of this. So if this is the case, let's see. If you are going our normal route, this is how we are going to deal with it. So we are looking at the first one, A, will be P. I won't write therefore. I'm just doing something. So my presentation may be, will not be the way that ordinarily you should have done, because I want to be very brief. So P, both are red. So it means more or less red. Am I right?
Yes, please.
So once both are red, like I told you, indirectly treat it as if you are dealing with selection without replacement. So in this case, then I'm going to use R sub 1, R sub 2. Take note. R sub 1, you know what the subs represent. You've been with me for a while. Here the sub indirectly is representing maybe your first selection, your second selection. But take note, with this one, the selection is done at once, at the same time. But I'm only introducing this just for explanation purposes. I'm treating it as if the selection is done without replacements, one at a time. So in this case, if you are going for your first selection, how many red do you have? 3 out of a total of 7. Do you agree? Times, if you are going for your second selection, the red will reduce by 1, because remember I said we are treating this one as if you are dealing without replacement. Your R will reduce by 1. So it means if you are going for your second selection, you get 2 of the R's there. Out of your S will also reduce by 1. So out of 6. So please do this, then give me the value. You know that 2 will go here, 3. So and 3 will go here. So you are going to get 1 out of 7. Is that clear? Hello, is my point well made?
Yes, please.
Okay, so don't. Okay, I remember I gave you an assignment, a research assignment. I've not forgotten at all. When we get there, and you are supposed to apply. I will ask you. Okay, so please, keep your fingers crossed and keep your research, intact. Your results that came. So now this is what we have. Okay, so let's see. We are going to let's do the B2 and see whether so B we are looking at both are white. Okay, or let me even do C because B and A similar. So let's do C. C we are saying one is red and one white. One red, one white. So if you are dealing with it, if you are looking at P, one R and one white, okay, what will be your probability? How would you find it? If you are going your normal way, assuming you've not been taught, and in fact, you've not been taught the combination approach to this. So how will you deal with it? Anyone to try? Hello, my professors, are you there? Okay, I don't want to mention names, so kindly volunteer to answer. Because we did this in core maths. So I want the core maths approach, sort of, which can also be used in elective maths. You know that anything that can be used in core maths can be used in elective maths, but not the other way around. So I'm waiting.
3 on 7 times 4 on 6.
4 on 6, that's it. Sally, were you the one?
Yes, please.
Okay, all right. So please, do you all agree? Lynette, do you agree?
Yes, sir.
Okay. Oh. You just made me sad. You remember initially, I told you, that this is the situation, and I expected you to correct me at a point. You didn't come, and in one of the videos, I had your attention drawn to that. I told you that if the order is not specified, then it means you are going to have more than a possibility if you are dealing with different, colors. Do you remember? Hello, Sally Nilet, do you remember? And the rest of
Yes.
you
Yes,
remember.
please.
So it means
Yes,
this one,
please.
you can see I said we are treating it as if we are selecting it one at a time without replacement. So it means, we are going to get two possibilities. One red, one white means maybe my first selection, so let me write this. So P, my first selection is red, my second selection is what? White. Or P, my first selection is white, and my second selection was red. Then you are good to go. Okay, so that's only the point. So at this point, I know without replacement, you can continue. However, if your first statement here, which is what you told me, is wrong, everything will be wrong. So you have to check whether indeed you are dealing with one possibility or more than one, possibilities. Is that clear? So if the question said, the first is red and the second was white, then it means that will be only this particular one because the order is rather specified. So if you bring in this, there will be a problem because this is not following that order. All correct?
Yes, please.
Okay, great. All right. So now let's move on to, so you can do that one, keep it. Okay, let's move on to, that approach because I've taught you that approach. So later you can do it and verify whether indeed the combination approach and that approach will result in the same value or result. Okay, so now let's see. Okay, so this time around we are going to look at what the combination words approach. So again, in probability question, if I read and I know items, I know their numbers, we should know the way to go. So what do? We are going to write, let solution first, the question number, what are we doing? S, we are dealing with what? Balls. So a set of balls, which you have some colors. So I have red, so R will be equal to a set of red, okay, balls. Okay, and your second one is what? White. So W will be equal to a set of what? White, okay, balls. Is my point well made? Now, if these are our representations, then we are going to get what? This implies that the number of S, okay, the number of balls, your total number of balls will be the two colors, okay, number add together. So that will give us 7. Do you agree? Hello, do you agree?
Yes, please.
Okay, so now you come to your number of R, okay, which will be equal to what? 3, okay, and your number of what? Of B, sorry, white, W, okay, being equal to what? Being equal to 4. So now the data fully extracted. So the information that you have here is what we have, okay, equally here. Now we go to, so when you read question, let's underline, okay, 2, so we are selecting 2, okay, of the balls. Okay, so then at the same time, okay, like I said. So now let's go and look at A. A, what are we looking for? P what? Both red, is that not it? So let me write both are red. Okay, so that will be equal to, okay, P2R. Do you agree? Hello, do you agree or I should come again?
Yes, we agree.
You agree? Okay, great. So again, just like the combination approach, okay, you are going to, yes, please.
That one, please. I want to ask a question.
Okay, ask.
Please, you see, when I read the question and it said at the same time, I thought that they meant like like simultaneously. Like it's not like you pick one red, then when you're done, then the probability reduce the balls reduce to 6, then you pick another red. I thought it was like they both have the same, like it's at the same time.
Yes, that is what I said. Per the question, that is, so it means immediately you dip your hand or whatever you are using to pick, okay, from the box, immediately you are picking, your hand will only come out when you have 2 balls, okay, in your hand. So you draw them at the same time. Per the question, that is how it is. Okay, however, remember I said the other one, I was explaining from the perspective that, okay, you are drawing, okay, more or less one at a time, okay, without replacement. Usually that is how we treat it. If the selection is done at the same time, okay, and you want to use the other approach. I don't know if you get my point.
Yeah, I get it.
Okay, however, with this one, I've told you the selection is not done. Okay, I said the selection could be done, okay, one after the other, not at the same time. So it's possible you will see your keyword, okay, at the same time there. But I can say that one after the other without replacement. You can see that though you don't see at the same time there, you see another keyword without replacement there. So, like I remember when I was introducing you to the condition, I told you that you have to see at least one of them, okay, in the question for it to be applicable. So, if immediately you read the question and you see without replacement, irrespective of whatever you have there, once you see without replacement, you can use combination. Once you see the selection done at the same time, okay, you can still use what? The combination approach, which is the same as at once. At the same time means at once. You get it? Indirectly.
Yes, please, I get it.
Okay, very good. Okay, so now you go by your own, okay, the way we were dealing with the combination. So you are going to select, okay, red from red. Is that not it? So it will be 2 red out of what? 3 red. So that will give us 3 combination 2 all over. Okay, now you still select 2 red out of the total, and the total we said is 7. So it will be 7 combination 2. All correct?
Yes, please.
Okay, so now this gives us what? Hey, I'm waiting. 3 combination 2. 3. Okay, 7 combination 2.
21.
Okay, so did you say 21?
Yes, please.
Okay, so now can we reduce this?
1/7.
1 over 7. Okay, can we go back? I just want us to do something. Okay, what did we get when we use the other approach?
1/7.
1 over 7. So you see the beauty of maths. So once you understand your stuff, okay, that's why we always don't have one way of dealing with it. Okay, so provided you do the right and you don't defy any mathematical principle, okay, and you don't use that approach, you get your answer, will mark you right. So always, okay, the scheme will come with that condition that accept valid alternative, not just alternative, valid alternatives. Okay, all right. So it's my point well made. Can we move on? Hello, can we move on? Are we all fine? Okay, great. Okay, so then we are going to move on to B. Okay, B, we are going to treat it in the same manner. So P, we are looking at both white. White. Okay, so remember we are looking at 2. So once you see both, obviously you should know that we are dealing with 2. Okay, so now P, both white means we are going to get 2 whites. And remember, I've told you, once you get your representation this way, you have to make use of it. Okay, take note. So now I'm going to squeeze the continuation here. Okay, so I need to go and select white from white. So I'm going to get 4. Okay, combination. I'm selecting 2. So 4 combination 2 all over. Again, I have 7 and I'm selecting 2. That is my denominator. So 7. Okay, selecting what? 2. So that will give you your denominator. We said will be 21. Now your numerator 4 combination 2.
6.
Okay, 6. Okay, so can this be reduced? Okay, so reduce it for me.
2/7.
Okay, 2 over what? Over 7. If you like, you can go and try using the other method. You end up getting the same results. Okay, only that the other method, especially where the items are, the categories, okay, are more, and you have more than one possibilities, you write more. When we get there, maybe I will give you a gist. Okay, for you to know that if it's relative math and the question is of this nature, the best way to go is the combination approach. That is, once you subject the question through the conditions for the use of the combination approach and the conditions are well met, then you go by this method. It's always ideal if this method can be used. You use it. Okay, so now we are going to move on to C. Okay, C, therefore, we are looking at P, 1 red, and, okay, 1 white. So you can say that each color. So 1 red, 1 white. I think, let me see if I can, okay, clear that. So with this one, how would you deal with it? Any suggestions? Okay, so that will be equal to, you write it using your, so it will be 1 R and, okay, 1 W. Is that clear?
Yes, please.
Yes,
Okay,
please.
so you go back to your combination. Okay, so with this one, you are not going to think of other possibilities. But the other one, you think of other possibilities. With this one, the other possibilities will be embedded in the combination that you are dealing with. Okay, because when you are looking at the number of selections, you always take care of all the other possibilities. So take note of that. So in this case, we are going to have, okay, 1 out of a total of what? 3. So 3 combination 1. Okay, then times, okay, 1 out of a total of 4. So 4 combination what? 1. All over, remember you sum. So 7 combination what? 2. So this is going to give us, your denominator we said will be 21. 3 combination 1. Any normal combination 1 is the number itself 3. Times any normal combination 1 is the number itself. So 4. So that will give us what? 12 on 21. But here you can simplify before writing 12 on 21. So simplify and give me the answer straight away.
Four over 7.
Okay, so 4 on 7. Is my point well made? Please remember, no one is going to be left behind. As for probability, it is a key, it is a constant that it will come. Okay, and questions of this nature, please make sure you are well versed. Okay, all right, so now D. Therefore, okay, this is the first question. That's why we are doing it together. So you know, subsequently, I'll be asking you, I'll be calling you one after the other to make me proud. Okay, or to make us proud. So let's go. Okay, D, we are looking at what? P. At least 1 red. Okay, so you know, immediately you see at least, we know what we are going to do. We won't stress ourselves. We know the relation. So it will be 1 minus P. Okay, no red. Is that clear?
Yes, please.
Okay,
Yes,
which
please.
will be equal to 1 minus P. Okay, how many? So if no red, then it means the 2 colors will be what? Or the 2 balls will be white. Is that not it? So 2 white.
Yes, please.
Okay, so as for this one, I know you are master. We are going to continue again, okay, from that side. Okay, so let's see. All right, so this will be equal to 1 minus, we've done 2 white. Is that not it? Both are white. So I think that is what we even have here. No, that was the B. Okay, so give me the value. You had 2 on 7 or 3 on 7.
2 and 7.
Okay, so that will give us 2 on 7. Okay, so this in effect will give us
5 and 7.
5 on 7. So this becomes the answer. Simplicity. All correct?
Yes, please.
Okay,
Yes.
so let's move on to the next one. Okay, we'll be looking at E and what? F. Okay, so let's see. Oops. Okay, so we are going to look at E. So E, what are we looking at? Therefore, P, at least white, 1 white. Okay, so this one too. At least. Okay, 1 white. Or you can use the number 1. Okay, it's equal to P. Oh, sorry, forgive me. 1 minus. Okay, no white. Is that not it? So at least, whenever you see at least, you use. Okay, so I didn't think before writing. So you can see I'm wasting time erasing, or I waste time to cancel. Okay, so now it will be 1 minus P, no white. Am I right? Okay, which in effect will give us 1 minus P, all red. So 2R. So that will give us 1 minus. Okay, the other one, you had 1 on 7. Am I right?
Yes, please.
Okay, so 1 on 7. Which will give us what? 6 on 7.
6 and 7.
So we are fine with this. So you can see that it's not difficult, provided maybe you do your very best to follow and ask questions where you are confused. Okay, so the F. Okay, therefore P. First is red, is that not it? First red, and okay, second, okay, white. Okay, very good. Take note, I want you to do this one, okay, using combination, keep it. I will not do it using combination. You will tell me your values. Okay, then after that, I'll come and give you a very vital information. So it means you have to take notes here, sort of. Okay, so let's see. Okay, how will you deal with this one? In terms of combination, what will you write? Any suggestions? Any suggestions? Oh, does that mean you won't write anything? My professors, are you there? Oh, someone should set the ball rolling. Okay, Laureen.
So please, I'm thinking there'll be separate fractions.
You
Like the first one will be, there'll be separate fractions.
okay? As in,
Like the first one will be 3 combination 1 over 7 combination 1
mhm.
times 4 combination 1 over 6 combination 1.
Come again.
So I was thinking that it will be 3 combination 1 over 7 combination 1
3
for
combination
the
1
red
over 7 combination 1.
times 4 combination 1 over 6 combination 1.
6 combination 1. How come 6?
Well, because the 4 should reduce after picking the red one.
Okay. Remember, I have told you indirectly, okay, that when we are talking of what combination, okay, you don't reduce this for now. So whatever that you do here, okay, take notes. If you sum, you should get exactly what you have there. If you sum, you should get exactly what you have here. In any case, my point is don't reduce anything in terms of your number. Okay, don't reduce. Okay, and very soon maybe you know probably why. Okay, all right, take note. Obviously, I know, you all know that if you go and do, okay, you treat this one as 1 red, okay, 1 white, then it means you are going to have 3 combination 1, okay, times what? 4 combination 1 all over, okay, 7 combination what? 2. Is that clear? And
Yes.
immediately you write it this way, then it means you are trying to tell us that, okay, what we have here is the same as 1 being red and 1 being white. So it's the same as the C. Indirectly, that's what you are trying to tell us. That what you have here is the same as the C. Do you agree?
Yes, please.
Which obviously they are not the same. Okay, with this one, the order is specified, but with this one, the order is not specified. So take note anytime, though in your question, okay, you saw the need, okay, for the use of the combination. Okay, anytime in the actual question itself, so this one is just the preamble. In the preamble, you saw the use of what? The possible use of combination. However, in the question itself, immediately in the question, the order of selection is, okay, stated. You can no longer use combination because combination, the order is not important. Is my point well made?
Yes, please.
So immediately the question tells you the order in which you are supposed to do your selection. Okay, you can see that with this one, it is the same time. Selection was done at the same time, but look at the way the question is put. First is red, and what the second was white. So it means you can indirectly treat it as you picking, selecting without replacement, one after the other. Is my point well made? So here, all that I want you to know is that anytime the probability question, which allows the use of combination in the preamble, okay, in the probability question, you see the order of selection specified. It means you can no longer use combination. Okay, those of you who have done permutation and combination, okay, which one considers the other, the order of our selection? In which one is the order very important? Combination or permutation? Hello?
Permutation.
Permutation. So it means, okay, usually we don't teach you the permutation approach to probability, but I will, introduce you to that briefly. But immediately you see that you cannot use, combination, then you have to go back to factory settings, which is our usual approach. So it means what you have here will be equal to, I can't use combination, so I will get P, R sub 1 and what? W sub 2. Is that clear? Okay, which will mean, what do I do? If R sub 1, I'm going to get my first one being red. So red, I will have 3 out of a total of 7. I hope you are following. Times, did you say no?
No, I said yes.
Okay, all right. So we are going to have the second one. Remember, the first red that was selected, was not replaced. Okay, so in that case, what will happen? If you are going for your second selection, which must be white, you still have your 4 white intact, so 4. However, your total is no longer intact. It has been reduced by 1, it's short of 1. So your total will now be 6. Okay, so compute this one for me and give me the answer. Okay, I will give you an alternative way. Okay, and we'll see whether we end
2
up.
over 7.
You had what?
2 over 7.
2 over 7. Please, do you all agree? Okay, great. Now, I want you to do this for me. Alternatively, let's see whether this is a valid alternative. Okay, so therefore, P, first red, and was second white. Will be equal to. We just said that when it comes to the order being important, it is for permutation. Is that not it?
Yes, please.
Okay, so it means instead of using combination, we'll use permutation here. So if we were using combination, then it will be 1 combination, sorry, it will be 3 combination 1. Am I right?
Yes, please.
Okay, and this one will give us what? 4 combination what? Combination also 1, because you are selecting 1. The same as 1 red, 1. So in terms of permutation, we are going to get, 3 permutation 1, then times, we go to the other one, that will give us 4 permutation 1 all over. Then again, it will be 7 permutation 2. Feed your calculator with the whole of this. Don't let us waste time on this. You are supposed to find this one, separately. Let's find it separately. 3 permutation 1 will give you hello, I'm waiting.
3.
Okay, then times 4 permutation 1.
4.
4. 7 permutation 2.
42.
42. Simplify that for me.
2 over 7.
It's the same. Can you see that?
Yes, please.
Okay, so this goes to establish the fact that immediately the order is stated, then the question moves from combination towards permutation. However, we usually don't teach permutation approach to probability in or at your level in SHS. But if you know, it's better. If you don't want to use this, you can go back to our usual way of dealing with it, which is what you have here. So ideally, this is supposed to be the approach. However, if you know the permutation approach, indirectly you have a little bit of upper hand. Is that clear? Is my point well made, or I should come again? Okay, so point is well made, right?
Yes, please.
Okay, very good. Okay, so with this, the G becomes trivial. You should be able to do the G. Okay, so quickly let's do the G, then go for our water break. So G. Okay, therefore, what are we looking for? Okay, so the first is red. So first P, first red. Okay, and okay, second white. Okay, so that will be equal to, we are going our usual routes. Okay, all right. So we are going to get what? P, okay, R sub 1 and what? Oh, first is white rather. Okay, and second red. Okay, let me clear that. Okay, then we come in. Okay, I'm coming. Okay, so it's rather first white, P first white, okay, and second red. Okay, and that will be equal to W sub 1 and what? R sub 2. Okay, so this will be equal to first white means if you go into the box, okay, if you go into the box, we are going to get how many, okay, white balls to select from? 4. So we are going to get 4 out of a total of what? 7. Then times the white was not replaced, so it will reduce your sample space by 1 and reduce the white also by 1. However, our second selection is not white, it's red, so our red is still intact, 3 over your sample space, which has reduced by 1, 6. So that gives us what? Hello, I'm waiting. That gives us
2/7.
okay, 2 over 7. Okay, now let's look at the alternative approach if you want to use, okay, the permutation. Okay, so therefore your P, okay, first white, okay, and okay, second red, okay, will be equal to, so you are looking at, okay, P, in this case you are going to get, okay, let's straight away apply the permutation. Okay, so let me write W. I can still write W1. Okay, then what? Okay, so it will be 1 W. Okay, then 1. Okay, right. Let me clear this and write it well. So, however, to remove the ambiguity, okay, because immediately you say 1 white and 1 red, then it means, okay, you changed the question. Can you see that? The meaning of the question has changed. Is that clear?
Yes, please.
So it will rather be still W1, okay, and okay, R what 2. When the order is specified, permutation all the way. So you want W, so you select W from W, but here you are not going to, you are going to look at in terms of permutation. So that will give us 4 permutation 1 times what? 3 permutation 1 all over what? 7 permutation 2. You know how to deal with this. So I'm waiting. Let me come and continue here. Give me the values that your calculators will give you. 4 permutation 1, 3
4.
permutation 1, okay, 7
3.
permutation 2, you said 42, right?
Yes, please.
Okay, so this also will give us,
2/7.
okay, 2 over 7. So whichever one sits well with you, you adapt. Is that clear? Only that if you can use the first one, use. Because usually this is the approach that will be, okay, stated, okay, or given in the marking scheme. All right. All correct? Hello, are we all fine? Okay. Kevin, are you there? Are you fine? Okay. Raphael, are you fine?
Yes, sir.
Okay. Janisha, you left along the line yesterday. Are you fine today?
Yes, please.
Okay. Cooks, are you fine? Cook, are you fine? Okay, so you are welcome back from the water break. So let's see, okay, how best we can deal with this question. Okay, so again, a bag contains 3 white, 5 yellow, and 4 red balls. So this time around, you can see that we have 3, okay, sets of outcomes, okay, or items, I should say. If 3 balls are drawn at random, so here you know that a specific number of balls are being selected without replacement, so the keyword is there. Find the probability that, so once you see one of the keywords and we can see one here, you know the keywords will be, if it's not committee, it will be at once or at the same time, then what, without replacement. We can see one here, so it means this question, okay, can fully submit to the application of what, combination. All right, so let's see, unless in the situation where in the question you see the order specified, then it means, okay, combination is no longer, okay, applicable. Okay, so let's go and see how best we can deal with it. Okay, so solution, as usual, we have to get our representation. So let's, okay, S be equal to, we are dealing with balls, forgive me, balls again. Then what do we have? Okay, we come to W, will be, we are looking at a set of white. Okay, so white. Okay, then, oops. Okay, then the next one will be yellow. So Y will be a set of yellow. Okay, marble, sorry, balls in this case. Then, and the last one will be, I think, red. Okay, so R will be the set of red. Okay, as for this one, if there are any marks for it, you shouldn't lose that mark. Okay, your representation is so easy, like I said. Okay, I've told you. Surprisingly, like I said in the exercise, someone couldn't get the representation right. Okay, this implies, now you go, number of S, we know will be equal to the sum. So 3, 8, okay, plus 5, 8, plus this will give us 12. Am I right? Okay, then we come to the number of W, white. White, we have how many? 3. Number of what? Yellow, Y. Okay, we have what? 5. Okay, and number of what? R. Okay, we have how many? We have 4. So we are good to go with this data that we have extracted. So what do? We come to A. A, therefore, we are looking for probability. Okay, they are all white. So probability that they are all white, or probability all white, and this will be equal to, okay, let me see if someone, okay, will give it a shot. Who wants to try? Hello, my professors, who want to try? Okay, patience, let's go. No, so write it in terms of, use your letters for convenience. 3W, very good. So all white will be this. Okay, so did you say, you said what, 3 combination 3? On 12 combination 3, perfect. Okay, so you are in a comfortable lead. Let's go. Any normal combination, the number itself is Ekome 1. 12 combination 3.
220.
220. Okay, so this is supposed to be your answer. As simple as that. So here, in actual fact, it should have been 3 white, 0 red, then 0, okay, yellow. But you don't need, immediately the others are 0. Remember, I told you don't write it to waste your time. Okay, so this becomes that of what? A. All right, so now B, we are going to look at B. Okay, where I need to come in, the one that I know you can solve without my help. Okay, I will call you. So, okay, Regina, let's go. We are doing the B.
Therefore,
P.
they are all
Okay, they are all.
red.
Okay, all red. Will be equal to
P open parenthesis 4R.
2 what?
4R.
No, how many are you selecting?
All red.
All red. So how many reds?
4.
No. How many are you selecting that 4 should be red? You see, you think because
3 are there.
you think because the 3 here, okay, you have 3 here, you think the 3 is for the whites. No, the 3 is for the number of what balls that you are selecting. So if all of them must be white, then it means it will be 3 white. Because you are selecting 3, okay, balls. Can you see that?
Yes, please.
Okay, so the 3 is for the number of balls that you are selecting, not for the number of whites. Is that clear?
Yes, please.
Okay, so give me the right thing here.
3 red.
Okay, 3 red. Okay, so which in effect, if you come and continue, okay, we are going to get
3 combination 4.
3 combination 4 pa. Come again. Your combination, you cannot have your R to be bigger than your N.
3 combination 3.
No. Okay, anytime you are writing combination, take notes. Okay, it is always N combination R. Your N is the total number of items that you are selecting from, and your R is the number that you are selecting. Okay, so here, the red, how many do you have?
4.
4. Okay, selecting means
4,
choosing
3.
how many? 3. Perfect. You see, once you understand, as for the combination, it shouldn't be a problem at all. Okay, so now let's go over.
Over 12 combination 3.
Perfect. Okay, so let's go. The denominator you know is what? 220. Okay, now your numerator. 4 combination 3. Is it 6?
4.
4. Okay. All right, that will give you 4. So now you know you can reduce this. So reduce and give me the value.
1 over 55.
1 over
55.
Okay, 5. Okay, please, do you all agree? Are we in agreement? Okay, great. So this becomes the answer. Okay, so with this all yellow, you should know how to deal with it. Okay, so our numerator will be, okay, it will be 3 yellow. So that will give us what? 5 combination 3 over the same 12 combination 3. All correct? Okay, so we skipped the C. We are moving on to the C, the presentation we have skipped. Okay, because I've explained. So you should be able to do that. So now let's look at D. So we are going to do D together. D, what are we looking at? P what? Okay, 2 whites.
2 whites and 1 yellow.
Okay, very good. 2 whites and, okay, 1, okay, yellow. Okay, so this will be equal to P, okay, 2W and what? 1Y. Am I right?
Yes, please.
Okay, which will be equal to you see you want 2 out of a total of what? 3. Is that not it? So you
Yes,
do
please.
3 combination 2, then times 1 out of a total of what? 5. So it will be 5 combination 1. Okay, all over. Let's go. Okay, our usual 12. Okay, combination. Am I right? Hello, am I right? – 12 combination 3. Am I right?
Yes, please.
Okay, so now let's see. Do you see anything that is not conforming to what I told you initially? Hello, can you hear me? Or you didn't get the question? Okay, so I'm going to proceed. All right. Okay, I was expecting you rather to draw my attention to. That is not to say this is wrong. Because remember I told you we'll make a decision along the line whether we'll have the usual situation or it is the always situation. Do you remember?
Yes, please.
Okay, so I'm moving on. You make that determination. That really we've made that determination. So let's go. Okay, so 3 combination 2 will give us
3.
3. Okay, 12 combination 3 will give us is here. That's the
220.
this here. Okay, so 220. Okay, so now simplify this and give me the answer.
Three on 44.
Okay, so 3 on 44. Please, do you agree? Okay, so this is what we have. Okay, take notes. This is what we are supposed to have. Okay, so at this point, this is what we need to do. Okay, so check. Okay, the sum here is what? 8. Is it the same as this? Okay, the sum here is 3. And that one is the same as this. So for your R, always, okay, what you have here, if you sum, it should be this. Okay, but for your N, okay, which is the N here and the sum of the N's here, okay, it is not always that when you sum, you get this. When you sum, you will get this always when you are dealing with 2 categories. But if you are not dealing with 2 categories and you are dealing with more than 2 categories, then it will not always be so. Bam. Is that clear?
Yes, please.
Should I come again or my point is well made?
Please come again.
Okay, all right. So remember all the ones that we started doing, okay, up to maybe the question 4. Okay, you realize that anytime you set up your combination fraction or your probability, okay, in that combination approach, you realize that anytime you sum the N, okay, you end up getting the N here. Anytime you sum the R's here, you end up getting the R in the denominator. Okay, however here, when you sum the N, it's not the same as the N here. When you sum the R, it's the same. And I'm saying that as for your R, it will always be the same irrespective of what you are dealing with. By your N, the sum, will not always be equal to this. It will only be equal to this when you are dealing with two items. Your selection is based on two items. And you can see that in our previous selection, we were looking at two items, either men, women, boys, girls, and even with the color situation, we dealt with only two colors. Do you remember? So
Yes.
with that situation, you saw that that was always the case. When you sum, you will get this. Okay, when you sum this, you get this. And I'm saying that anytime you have more than two, as for the sum of the R giving you this, that one is always, but this will not always be so. All correct now?
Yes.
Okay, great. Okay, so now if that's the case, then we can move on to our E. Okay, so the E, indirectly, we are going to deal with it in a similar way. Okay, so E. Okay, therefore, okay, what do we have? We'll do E but not do F. If you're able to do E, you should be able to do F. Okay, we are looking at what? 2 white and 1 red. So 2, okay, white and, okay, 1 red. Okay, which indirectly will be, okay, P, 2 W, and what? 1, okay, R. Okay, so that will give us, okay, we know the W you have what, how many? 3. So it will be 3 combination 2 times the R, how many? 4. So 4, we need only 1 all over, okay, our 12 combination what? 3. So from here, you should be able to proceed. So help me proceed. Okay, so 3 combination 2, we know will still give us what? The 3. Then times, okay, 4 combination 1 will give us 4. All over 12 combination 3, which is 220. Okay, so this simplifies into Hello? My professors, are you there? Hello?
55.
Okay, come again.
3 on 55.
3 on 55. So that then becomes your answer. So with the F, okay, it's the same way. So we are going to have 2 yellow, okay, and 1 red. So that will give us, we select the 2 yellow from the number of yellow. So it will be 5 combination 2. And so times, okay, 1 red. You select the 1 from a total of, okay, 4 red. So it will be 4 combination 1 all over your 3, okay, that you are selecting from a total of 12. So 12 combination 3. Safa. Okay, so now let's look at, okay, the last one, which is the G. Okay, so G, what are we giving there for? We said they are of the same color. So P, you can write same color, or they are same color. I am going to write P, same color. Okay, so on that note, this will be equal to P, okay, same color. Take notes. Okay, this is what we are going to have. If you are thinking of same color, what comes to mind? If the balls must be of the same color, okay, is there only one possibility or more than one possibility?
More than one.
More than one. So it means you can have P all white, P all what yellow, and P what all what red. Is that clear? So you are going to have this P, okay, all white will be 3 white, or P, another possibility, 3, okay, our second color, yellow, or, okay, the third possibility, okay, the, or what, red. So 3 are. Is my point well made?
Yes. Yes,
Okay,
please.
so I am going to ask a question. Okay, just by the way, assuming I had the number of whites to be 2. Okay, the number of whites to be 2. What will be the number of possibilities?
Okay.
Should I come again? Should I come again, or you get my question?
Please come again.
Okay, so I said, assuming in this question, the number of white is 2, it's not 3, but the rest the same, and you are asked to deal with this. Okay, they are of the same color. What will be the number of possibilities? You know that this one, the number of possibility 1 is this 1, so you have 3 possibilities. Do you agree with me with the original question?
Yeah.
So if I change this one to 2, or this one changes to 2, what will be the number of possible ways? Or the number, it will be 2. Why?
Because the white is not up to the number of
Perfect.
possible.
As simple as that. So if you come and write 3 white, when you are going to do your combination, you know that there will be error in your combination, because you are going to write more or less 2 combination 3, and you cannot have 2 objects and you select 3 from. Not on this planet. Okay, all right. So take note of that. So it's not always that because you have 3 colors, you have 3 possibilities in this situation. It depends on the number of items that you have in your colors as well. Okay, so now let's go. Having answered that question perfectly, now let's go. So this will give us what? 3 combination 3, am I right? All over 12 combination 3. Do you agree? Okay,
Yes, please.
all is plus. We all know that. So you come here too. So that will give you 5 combination 3 all over 12 combination 3. Am I right? Okay, then plus the other one will give you, the number of red, you have 4 combination 3 all over again 12 combination 3. Is my point well made? Okay, after that, I will give you a refined way of writing, whatever that you have here. So which in effect will be equal to, you come and do them separately. However, as you mature, take notes. Whatever you wrote here, you can write it this way. Take notes. Okay, I think from here you can proceed. Is that not it? The rest will just be calculator work. You use this one fraction. They will all have the same denominators. So you just add their numerators, keep the common denominator. If simplification is necessary, you do that. So in this case, I can write P 3 whites. I'm putting everything together. Or 3 yellow. Or 3 red. So I have everything together. So in that case, when I'm writing it, this is how I'll write it. I'll write it as 3 combination 3 plus, now 5 combination 3 plus what? 4 combination 3. The whole of that over my 12 combination 3. And you can see that it's evident here. So this one is a single fraction form of this. Here you separated your odds in terms of the probabilities. Here you combine. So that's also another way of presenting your solution. All correct? Okay, just as when you had the end, you could use the end and then you will just multiply. You can also deal with the all together as well. Okay, so if that's the case, then let's move on to our next question. All right, so let me see. Okay, all right, so if you have issues with your network and you are unable to follow, sorry, wait for the video, then you have full access to an uninterrupted lesson so that your understanding equally will not be interrupted. Okay, all right, so Here we are. I'm going to call you one after the other. Okay, then we'll deal with this question. Okay, let's see. Okay, give me some time. Let me see. Think through the question. Okay, so quickly, let's see. When you read the question, check whether the combination approach, is applicable. So the selection is done at once, so you can see one of our keywords there at once. Okay, and we are selecting again a specific number of what? Of bulbs. Okay, or items. So quickly, let's go and look at the solution. As for the representation, we all know we'll get the full score for the representation. So let S be equal to, this time around, you are dealing with what? Bulbs. Okay, so you are going to have, then your first color is red. So R will be, a set of red bulbs. Okay, then what do we have? B will be equal to a set of what? Blue bulbs. Okay, and your last one will be white. So W will be equal to a set of what? Of white, bulbs. So this implies that our number of S will be equal to, if you add, this gives us 11. So we are going to get 20. Am I right?
Yes.
Okay, so your number of R, what do we have? 7. The number of B, what do we have? We have 4. Okay, and the number of, W, what do we have? We have 9 of them. Okay, so now we come to A. Are we following?
Yes, please.
Okay, very good. Okay, so now what do we have? We are going to look at, they are of the same color. So where we ended. So therefore P, same color. Or they are of the same color will be equal to. Okay, so let's see. We have 3 categories. Okay, that is red, or colors, red, blue, and white. So let's check. We are picking 3. You can see that all your categories that you are looking at, the numbers more than. Okay, so if you have your numbers equal to the number, that you can still deal with it. So it means here we are going to have how many possibilities? 3. Okay, so we are going to have 3. Our first color is what? Red, or
Blue.
3. B, or
3.
3W. Okay, then you close it. I hope you are following. Okay, so that will give us what? In terms of the red, we are going to get 7 combination 3. All means plus. Take notes. Then B, we have 3. We are selecting 3, but how many of them? 4. So it will be 4 combination 3. Then plus, or we have white. How many do we have? 9. So 9 combination 3 all over. Okay, so what do we have? Okay, so we are going to get what? What combination? 20 combination what? Combination 3. Okay, so if you look at this, you can see that because the probability that you are looking at involves all the colors, when you sum, your N, it will be the same as this N. When you sum so in this case, because you are not, what do you call it? You are not multiplying. Okay, this will be the same as this. You don't sum. Okay, take notes. Okay, so it's the same situation. So, like I was saying, if your probability that you have there involves all the colors, what we said will always hold. Otherwise, it will not be so. Okay, so now let's go. 7 combination 3. Come again. Wow, did I hear 31?
35.
35, okay. Then plus 4 combination 3.
4.
4. Okay, plus 9 combination 3.
84.
84. All over 20 combination 3, a huge number.
1140.
1140. Okay, so at this point you are in a comfortable lead. Okay, your denominator, write that one first. You have little or no work. Then you come to your numerator, add that for me.
$123.
Come again. 900 and
123.
123. Okay. 1, 2, 3. Okay, so can you reduce it?
Yes, 41 over 300.
Okay, so 41 over 300, okay, becomes your answer. As simple as that.
380.
Come again.
308.
About 300.
380.
Yes, please.
Okay, all right. So not 300, 380. Okay, so that will be it for the solution to this, okay, assignment. Okay, I'm sorry, did I say assignment? This question. Okay, so the B, okay, we are going to look at it, okay, also from. So let me see if you can squeeze it here. Okay, so you are going to do the B here. Okay, so B. Okay, therefore, what are we looking at? P, one of each color. One of each, okay, color. Okay, and this will be equal to, who can help? We have 3 bulbs that we are selecting, but we are saying that the condition is that you should have one of each color. So what would that mean? It will be P what?
One red, one blue.
No, one red, one. I want a certain connector. One red. Is it all? And okay, all right. So one red. Okay, and what? One
Blue.
one what? Blue and okay, one white. Is that clear now? Is that okay?
Yeah.
Okay,
Yes.
so in effect, we are going to get what? One red, you know. We are selecting as how many reds do we have? 7. So it will be 7 combination 1. Okay, then end is multiplication. 1 blue will be how many? 4 combination 1. End multiplication. White 9 combination 1. Okay, all over, you always have a denominator, and that will be your 20 combination 3. All correct?
Yes.
Okay, so now help me deal with it. Okay, I know my denominator is what? 1140. Okay, so my numerator 7 combination 1, 7. 4 combination 1, 4. 9 combination 1, 9. Okay, so you are in a comfortable lead. Okay, so what on 1140?
140.
No, what on this?
100.
What's the numerator? Hey, you are adding or don't multiply, please. You are adding. Oh, sorry, you are multiplying. Forgive me. I'm rather wrong. Okay, you are multiplying. Forgive me. Let me do the change there. Okay, quickly. Why was I adding? Okay. Oops. Okay, no problem. I will effect the change. Oops. Okay, no problem. I can effect the change. Okay. Okay, so this one was plus 4 plus 9 all over. Hey, did I have written plus again? Okay, multiplication. So it means this is likely to happen to you. So please take note of that. Hey, what would that give us?
140.
1 or 4?
140.
Okay, so now this gives us
7 over 55.
7
57.
over 57. Okay, if she is right, I'm also right.
Last one, the
Yes,
denominator.
it's 1-1. One has.
Formula.
I think when I was, it's the one. Okay, all right. So thanks for, drawing my attention to that. It was when I was erasing. Okay, let me erase it and do the right thing again. You are thinking of doing the second one. Okay.